Welcome back, geometry students. This is chapter 9.4, compositions of isometries. So if we're breaking down the word isometry, I bet you guys are thinking, what does this mean? So iso means same, and metry is a root word for measure, so same measure. So if we undergo a transformation and it still has the same measure, that is an isometry. So it's essentially another way to say a rigid motion. Okay, so there's a little bit of nuance depending on which region you're talking about mathematically, but in my view, isometry is synonymous with rigid motion. So if we're talking about rigid motion, we're talking about four types. So the first one, the black is the preimage. So if we're looking at this is the preimage. Okay, and then the blue is the image for all of these, just so you're aware. Now, so what happens here? Well, we have the preimage go from one position to another. The arrow is the same for all of these, okay? It's the same measurement for all of these. I just copied and pasted the arrow. So it is all examples of isometry, and the first one is translation. This is a good reminder, good review of the different types of rigid motion and isometries there are. The second one is rotation. Okay, so we went from vertical or northward facing arrow to an eastward facing arrow, so that is a rotation. And of course there has to be some sort of center point of rotation and some sort of angle measure in which it rotates. This third one goes from north to south, and this is a reflection. Great song in the movie Mulan. If you haven't heard it, go ahead and look that up. And this one, so this is kind of leading us into the next concept that we're going to be doing soon after. This is what's called a glide reflection. A glide reflection. Now, what do you notice about the glide reflection? Is there's two things going on. Number one, it's translating. It's going from here to here, and then it is reflecting. So two different transformations undergo to give you one type of new transformation, which is called glide reflections, okay? And this is called a composition. So anytime we have more than one transformation, it's called a composition. Think composite words. So that's more than one. Composite materials, or excuse me, compound words, not composite. Compound words, composite materials, more than one, okay? Composition, more than one. Okay, so now we're going to get into some notation. So our new notation, and this we're going to use this specifically with this example in just a moment. But this notation, we have, if we had this, we would know what this is talking about. This would be talking about a reflection across line L. R, big R stands for reflection. The L is the line that we're talking about reflecting over, and then ABC is the preimage. Okay, but now what does this new symbol mean right here? Okay, let me use red so it stands out a little bit more. This is composite. So we are going to do a composition. Now, how do we know which one to do first? Well, the composition we always do first is closest to the preimage. So there's the preimage. We always apply the transformation that's closest to the preimage notation. Okay, the preimage notation first. Okay, so then after we do that first transformation, we're going to go ahead and do our second transformation. So the one that's further away, we do second, okay? Now, both of these are reflections, which is okay. You can do more than one reflection. I mean, you can do anything you want, but just keeping in mind, we do the one to the right first, and then the one to the left second, okay? The one that's closest to the preimage first, okay? And this is something that you're going to do in Algebra 2 also with composite functions, as well as some other of your math courses. Okay, back to reflections across parallel lines theorem. So let's take a look. Here we have a preimage. Here's our preimage, ABC. And we have two parallel lines, line L and line M. What happens if we reflect ABC over the line? Well, it's the mirror image, okay? It's like yourself looking in the mirror, you scratch your right ear, you look at yourself in the mirror, and the person in the mirror is scratching their left ear. Whoa, what is going on? Don't worry, it's just the mirror image. Now, what happens if you get a second mirror behind you and you see your face in the second mirror? Well, you would see the reflection again. So you would see it corrected. Well, let me show you how that looks. Maybe the look in the mirror wasn't the best example for you guys to get your facts straight, but let me show you. So let's say we first reflect the pre-image ABC and we have this image. Now, what happens if we decide to reflect this image again? Okay, so now we're going to treat this as a second pre-image and we're going to reflect it again. What would it look like? Well, just going off of a basic diagram here, it would look something like this. Because remember, the angles have to be in relation to each other. The distance needs to be preserved. The distance from A prime to, let's call this A double prime. That distance needs to stay the same. These angles need to be proportionate. And I'm not proportionate. They need to be the same. Okay. So now, how does this image, let me label it. How does this image compare to the original pre-image? It is the same, okay? It's in the same orientation. So what happens is a reflection over parallel lines becomes a translation. So what we can do is we can write it like this. So a translation of some x and y value of pre-image A, B, C becomes the reflection of line L first, because that's the first line, and then line M. Now keep in mind this only works with parallel lines. That's a very important point. So keep in mind that if you have a reflection over two parallel lines, it becomes a translation. So essentially we can write this becomes a translation. Okay, it's equal to a translation. Now we're going to do one more theorem and then we're going to set you guys loose for this particular video. Okay, I think we've covered enough. So let's go ahead and look at our second example, or in our second case. So reflections across intersecting lines theorem. So now we don't have parallel lines, we have intersecting lines. Again, we have a composition here of functions. Which one do we do first? We're always going to do this one first. So if we're looking here, the first thing we're going to do is we're going to reflect over, big R means reflect, over line M. Okay, this is the closest thing to the pre-image notation, so we're going to reflect over line M first. So if we reflect over line M, it's going to look something like this. I just need to give you an idea. Okay, it doesn't have to be exact. Just need to give you an idea. Okay, this is what our image looks like. So this is called C prime. Let's call this one B prime. Let's call this one A prime. Remember, we need to maintain distance to the line of reflection. There we go. Okay. Now, because this is a composition, we're going to do a second thing. What is the second transformation? We're going to reflect, that's what the big R stands for, over line L. So now we're going to reflect this guy again. So let's do that again. So we're going to have something like this, okay? It doesn't have to be exact. I'm just kind of giving you the rough idea of what's going on here. Ooh, that was a little rough. I need to get this a little bit more of an obtuse angle. Okay, I know I said it didn't have to be exact, but even that bothers me. Okay, so more of an obtuse angle right there. That's looking a little better. Okay, close enough. So we have B double prime, A double prime, and then C double prime. How do these relate to each other? Well, you're probably noticing that if we reflect twice, okay, it's like you flip your paper over. Well, you have your backside up, but if you reflect it again and you flip the paper over again, now you have it up the original way that you did, okay? So if you do two reflections, you're essentially reorienting it back in the original fashion, okay? So you're like taking away the mirror image. Now, how are these related? Okay, we already know that these are reflections and these are reflections, but how is the original preimage and the new image related to each other? It is a rotation. Notice how, if we look at this, okay, and let me copy and paste ABC for a second. You're going to see that I didn't get the proportions quite right, but if I were to rotate this guy around, I would get something, whoops, I don't know how that happened. I would get something, doesn't want to go. Well, he's gone. He would get something like that. Okay, so I would reflect him, rotate twice, I get a reflection. Actually, I did a pretty good job. See how that happens? If I do two reflections, it's the same thing as a rotation. So now I just need to notate this. Where did that go? It's unsolved mystery. So a reflection, a double reflection over intersecting lines is the same thing as a rotation. So keep in mind that some x degree over some point, in this case it's O, of A, B, C. And I could put the triangle sign, but it's the same thing. Okay, so it is the same thing as rotation. That's all I want to show you guys today. Be sure to come back so we can talk over some glide reflections. It looks like my iPad's had enough. Go over some glide reflections, and then we will finish up with an example of a composition.